Remember not to write all your math papers in ink. Remember to show all your work if you don't want to see. Remember the test day and prepare for it wholly, because if you don't, then you'll perform poorly.
Hey guys, let's go over 1.511 model, that's what I should say, model with quadratic functions. Alright, go ahead and do this problem with me. We're gonna do a bunch of stuff here. So a firework is launched 1 foot off the ground at a velocity of 128 feet per second. Hint: use h of t equals -1/2 gt squared plus vt plus ho, where g equals 32 feet per second squared. That's gravity. Okay, so let's draw a picture. And this 1 foot off the ground is this ho. And this is what's happening, right? And basically what we're going to do is we're going to write an equation. So let's do that. Let's write that. H of t equals -1/2 gt squared plus vt plus ho. And let's go ahead and highlight all the information we have. We have 1 foot off the ground. So I'm going to go ahead and write there a 1. Okay, it's telling us that g equals 32 feet per second. So anytime you see g, we can write that. Now basically what we're going to do is we're going to be solving for t, and I don't know why I didn't, but I normally write t with a capital. So you see how it makes me look like my plus signs? That's why I do a capital T. And what we're doing here is your equation, what you're solving for is t. And one last one is, what is velocity? Now it's telling us the velocity. You can ask your science teacher, but velocity is essentially like speed. Okay, so this is what I have here. Height in terms of time is equal to -1/2 32 t squared plus 128 t plus 1. And if you simplify that, you will get this formula. Oh, we said capital letters, right? Wah. -1/2 of 32 is just -16 t squared. Okay, I want to say that if you get stuck on this type of equation, you can just make it in terms of y's and x's. I just didn't want you to be intimidated by it. That's all. Okay? So either of these would be an acceptable function. Rewrite the function in vertex form. Let's take the one in green. Doesn't really matter. That's what you guys are used to. Okay, so this would mean, you know, -16x squared plus 128x, and then to complete the square, before I do that, I'm going to factor out a -16. And 128 divided by -16 is -8x. I forgot my plus 1. Okay, so then inside the parentheses here, my b value is -8. Okay, if I put 16 here though, remember you might want to do this in between step and just distribute this and you'll figure out what you need. -16x squared plus 128x, and I believe that's going to be -256. So if you're doing a negative 256, then you're going to have to put negative 256 in that positive 256, because they have to be opposites. They have to add equal 0. Saving image. Okay, so come on, saving image, please. Patience is a virtue. Okay, y equals negative 16 plus 257. If I factor that, inside you have 16, negative 8, so that would be negative 4 and negative 4. And that's my answer in vertex form. Find and interpret the axis of symmetry. Okay, so if you draw a picture, let's use a color we haven't really used. Let's use purple. The axis of symmetry is here. And what do you notice? It's going to divide it into two halves. Let's write that. The AOS, axis of symmetry, divides the parabola in half. And the height of the firework is the same before or after 6 seconds. So where did I get the 6 seconds from? So if you take your H and K, so A is negative 16, so I know it's negative, so it's opening down. My H value is 4,257. So if I go back up here, this is 4,257. So this is the X, this is the Y, so Y represents the height measured in feet. And then the X is what? Time. So they're saying that if this is 4 seconds, that means this is going to be 0, that's going to be 4, and this is going to be 8. So it takes 4 seconds to get to the height. And now it tells us to interpret the that should be 4 seconds. So what I meant by that was like, well, watch. Let's use highlighter. So this is taking 4 seconds, and then this here is also taking 4 seconds. Okay, interpret the find and interpret the vertex. So the maximum, why is it a maximum? Because it reaches its highest point. So the maximum of the firework reaches, what was your Y value? 257 feet after, so I'm going to put that's your Y axis, after how many seconds? After 4 seconds. Okay, so we're just putting some application to our quadratics. And now, for questions 50 to 51, complete one and go ahead and skip one problem. Number 50, the height of a firework at an amusement park celebration can be modeled by a quadratic function. Suppose a firework is launched from a platform 2 feet off the ground at a velocity of 96 feet per second. Use the same formula. So let's draw ourselves a picture. And this point is going to be 2 feet off the ground. That'll be our HO. So here's the firework. Let's go ahead and write our function. I like to write capital T's. Saving image. Oh no. Okay, let's substitute in some values that we have. We already said that the platform of 2 feet off the ground is our HO. Our velocity of 96 feet, V for velocity. Notice the T is still there. And then gravity, that's what G represents, I think. It's a constant, which means the same value, is 32. So you have H of T equals negative 1/2 G T squared plus 96T plus 2. And of course you can just clean that up by multiplying negative 1/2 times 2, so that's 1 times 32 and 2 times 1, so 32 divided by 2 is negative 16. And again, I want to say that you can make this into x's and y's. Whoops, that should be a t. So you have some options here. If you're not intimidated, use the h of t. It looks better and fancier. If you can, then go ahead and use the x's and y's. Alright, let's go ahead and write this in vertex form. Magic. Okay, what are we going to do first? Let us factor out negative 16. This will give us x squared. 96 divided by 16 goes in 6 times. Yep. Okay, now the math operations are changing here. Why did I write 9? Because if you distribute, you can check your answer. Okay, let's complete the square. CTS. So b over 2 squared. My b value is, pay attention, inside the parentheses, negative 6. And this will give me a 9. Now, pay attention. If I write a plus 9 here, what am I going to put in this box? If you distribute here, you'll get, we're trying to get equivalent expressions, negative 16x squared plus 96x, negative 4, 5, negative 144. Okay? What does this mean? If you had the plus 2 over here, you would have to add 144. Do you see this? The yellow boxes add to be 0. So really, this plus 9, it's really negative 16 times 9, which gives you negative 144. So you would have to put in positive 144. Because we're trying, again, yellow boxes, add them together is 0. So from the green to the blue line, they're still equivalent. They're exactly the same. From the blue line to this third kind of like mostly black line, they're the same. Okay, let us factor here. Remember, we've been doing this, not trick, but if the a is 1, then I only have to use the x. Why? Do you see my two numbers, negative 3x? Those will be my answers. You might be asking, Mr. Eng, how come you took so long to tell us this? Well, how come it took you so long to observe those patterns? That's part of math. See? Becomes up negative 3. Plus 146. Okay, so that is vertex form. Let's go ahead and box my answer. Oops, sorry, I'm throwing my pencil at you. Has a power of 2 there. Find and interpret the axis of symmetry. Basically, it's the same. You could just write same thing as you have over there. What's the only difference for this one is it's the same after how much time? 1.5 seconds. Sorry, 3 seconds. Let's write the ax minus h squared plus k 146. So this is the x-axis, this is 3, that's 46, and this is a maximum, right? Our vertex is a maximum. So what does the axis of symmetry do? The axis of symmetry cuts my parabola in half, right? They're equal distance. This is 3 seconds, and this is 3 seconds, or use a geometry congruent. Okay, interpret the, we could do the same thing. The vertex is a maximum height of 146 feet after how long? 3 seconds. So I'm getting those numbers from here. Okay? Alright, let's try this one right here. Question number 51. Malik is participating in a diving championship. For each of his dives, his height above the water can be modeled by a quadratic function. The diving board is 7.5 meters above the water, and Malik jumps with a velocity of 4.18 meters per second. Now we're using meters, which is 9.8 meters per second squared. Okay, so 7.5 above, so if this is the water, this is my diving board. Deet, 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 deet. There's Malik. Okay, that's at 7.5. Well, sideways parabola. I think mine's better, huh? Okay. Let's fill this out. So h of t, I talked about using capital T's. They call that initial height or starting height. So 7.5 right here. .5 meters, right? So this is height in meters. And what else do we have? We have G. G is 9.8. Don't worry about the units. And last one we need is velocity at 4.18. Here is velocity. H of t equals negative 1/2 times 9.8 t squared plus 4.18 t, and 9.8 divided by 2 is 4.9. So h of t equals negative 4.9 t squared. Remember, 9.8 is not squared. Plus 4.18 plus 7.5. Okay, so let's go ahead. Saving image. Alright, so let's work with this one. H of t equals negative 4.9 t squared plus 4.18 t. And then I have this 7.5. Okay, let's factor out a negative 4.9, because to complete the square I want a value to be 1. So t squared, so now I'm going to do 4.18 divided by negative 4.9, negative 0.85. Negative 0.853. Okay, so I need to get something into this green box. And I'm going to draw another green box kind of in between. So our CTS is b divided by 2 squared, which is 0.853, negative 8.53 divided by 2. We're going to square that. So negative 0.853 divided by 2 gives me negative 0.4265. And now we're going to square that to multiply by itself. And we're going to get 0.18 0.819. Okay, so that goes here in the green. Well, this green. And so if I do the in-between step, let's do purple. If I distribute this back out, right, this will give me negative 4.9 t squared. What's above is 0.418 t, and negative 4.9 times 0.1819 gives me 0.89131. Okay, so that means this will become a positive 0.89131, And that's why here in this next line, they are not the same numbers. Okay, let's now factor. And I'm factoring to help you understand. We're just factoring that yellow box. So A times C is 0.1819. My B value is negative 0.853. Two numbers that multiply to be 0.1819 is that number, negative 0.4265. Let's double check. And I get 0.1819. If I take 0.4265 plus 0.4265 negative, I get 0.853. So, negative 0.4265. Now again, you can put it into the box and you'll recognize that the numbers will be the same. 7.5 plus 0.89131 gives me 8.391. And this is my answer in vertex form. Let's find the vertex so we can kind of graph this. So A is a negative, and negative people do what? Down. They're down on themselves, so opens down. H value is 0.4265. And the key value is 8.391. 4265. 8.391. And this is our maximum. And this should kind of help make sense about why it's this is 0.4265 and this is also 0.4265. And if you multiply those two numbers together, you will get 0.4265. What? 0.4265. This will be 0.853. So after less than, what? Why did I write height? Sorry, yelling at myself. This is time. This over here is time measured in seconds. Okay? So the axis of symmetry cuts the parabola in half. So the max height of the parabola is the same before and after how many seconds? 0.4265. seconds. And then the vertex is a max height of 8.391 meters after 0.4265 seconds. That thing must be flying. It's getting out really fast in a short amount of time. And that was 1.511. We'll see you guys later.